Back to a new video. Today we are going to learn how to solve GCSE arithmetic sequences. These type of questions are easier than quadratic sequences. However, it is a very important, a basic first step you need to know for quadratic sequences, or how to solve quadratic sequences. It's very helpful. So, arithmetic sequences are a sequence of numbers which increase with the same addition each time. So from 6 to 11, you add 5, and then you add 5 every time. So add 5, add 5, add 5, add 5. And it asks us to find the nth term of the sequence, or the. Yeah. So we can do this by finding the difference and then placing it as the coefficient of n. So plus 5, plus 5, plus 5, and plus 5. The coefficient of n is a number which you place in front of n. So in this case, it's 5. So 5n will give the formula 5 multiplied by 1 when n is 1, which is 5. 5 multiplied by 2 when n is 2, 10, and so forth. And then you look at what the difference is between this equation and this equation. So how would you get from 5 to 6, and from 10 to 11, and from 15 to 21? No, from 16, and from 20 to 21. You add 1. Therefore, the equation is 5n plus 1. And that's the answer. That's the nth term of that sequence. Okay, so now let's move on. So here, the first 4 terms of an arithmetic sequence are 21, 17, 13, and 9. In terms of n, find an expression for the nth term. So the expression for the nth term is the equation that we got. So here it subtracts by 4 each time. So 21 minus 4 is 17, minus 4, and minus 4. And now you just put that as the coefficient of n. So negative 4n. Then you write the formula of that negative 4n, and you will get negative 4 multiplied by 1 is negative 4. Negative 4 multiplied by 2 is negative 8. Negative 12. Negative 16, and so forth. Then you look, how would you get from negative 4n, or negative 4 to 21? Negative 8 to 17, 12, negative 12 to 13, and negative 16 to 9. So you have to subtract these two from each other, and you'll get 25. So you have to add 25 to get from that to that. And let's see if that's also correct for this one. Minus negative 8. That is also equal to 25. Therefore, the expression for the nth term of this sequence is equal to negative 4n plus 25. Okay. And let's move on to the last one. In this question, it asks us to find the next 2 terms. This you could also figure out in your head by just looking at the first difference, plus 5, plus 5, plus 5, plus 5. And then you can just easily add 5 and add 5 again. So, however, if the numbers become larger, or if the differences become larger, it is easier to find the nth term first, or the expression of the nth term. Therefore, let's put 5 as the coefficient of n. Let's write down the equation, the sequence, which is 5, 10, 15, 20, 25. In this case, it's 5, ... because there's also 5 there. How do you get from 5 to 3? you subtract 2. Therefore, the equation is 5n minus 2. So now you have to find the next two terms. This is the first term, second term, third term, fourth term, fifth term. And you have to find the sixth term and the seventh term. So to find the sixth term, we plug 6 into n. So n will be equal to 6. And that is the sixth term. So 5 multiplied by 6 is equal to 30. Minus 2 is equal to 28. So this is the sixth term. And the seventh term is when n is equal to 7. And then let's plug that in. And 7 is 5 multiplied by 7 is 35. Minus 2 is 33. And that is when n is equal to 7. So that's the seventh term. So that is the answer, 28. 33. Thanks for watching. I hope you understand how to solve it now. And please comment down below if you still have any questions, and I will talk about it or make a new video. Thanks for watching, and on to the next video.